How about 3 breakthroughs in robotics, where each has earth-shaking potential for fame and fortune? Capsule Robotics, the all-robot auto plant, and Cobot's next great gift to industry, the Cobot Dexterous Hand. In the future, all surgery will be non-invasive. Anyone who has experienced the odd discomfort of a colonoscopy would no doubt readily opt to swallow instead a 22 by 11 millimeter medical device, about half the size of a wine cork, that can perform the same procedure as a colonoscope and much more. Technology for such a new medical device has been developed. It may be at an inflection point that, much sooner than later, pushes it into the marketplace for widespread use. With an astounding 19 million colonoscopies performed annually in the U.S., Capsule Robotics could dramatically reduce the average $3,000 cost of the procedure, not to mention the relief from dread for millions of patients. A new study by Pierre Dupont et al., called A Decade of Retrospective Medical Robotics Research from 2010 to 2020, explains how instrument-free, non-invasive diagnosis and therapy inside the digestive tract will be performed through a new branch of robotics, Capsule Robotics. Around the year 2000, Given Imaging, now Medtronic, put forth the possibility of collecting images deep inside the bowel just by swallowing a pill. It revolutionized the field of gastrointestinal endoscopy and sparked a brand new field of research. The major challenge? Integrating complex mechanisms, including an adequate power supply, into a pill-sized device. A breakthrough approach has arrived. Magnetic actuation solves this limitation. The use of magnetic coupling bypasses the need for intricate mechanisms and reduces onboard power needs. This form of actuation manipulates the capsule, containing an embedded magnet, via an externally generated magnetic field. This mechanically simple arrangement can precisely control capsule orientation, motion, and navigation. Basically, Capsule Robotics combines the use of robotics, computer vision, and advanced magnetics, enabling even non-expert users to effectively perform magnetic colonoscopy, which, of course, is an awesome consideration. The medical expense and the forecast of a 16% increase in procedures would be drastically reduced. Capsule Robotics for robotic endoscopy is non-invasive and inexpensive for colonoscopies, as well as in a variety of applications where navigation in unstructured environments is required, such as catheters, pancreatic endoscopy, bronchoscopy, and gastroscopy. Maybe soon, when your doctor schedules you for a colonoscopy, you can ask for the pill. During a tour of Nissan's auto plant in Bangkok, I was treated to a seemingly endless train of individual mini AVGs loaded with automobile parts, following a floor track and winding their way from one workstation to another throughout the facility. I remarked that it was amazing to watch, but I was told in polite English, "You ain't seen nothing yet." In Japan, it seems that only smart robots need to apply for work at Nissan's brand new intelligent auto plant. Nissan Executive Vice President Hideyuki Sakamoto said up till now, people had to make production adjustments through experience, but now robots with artificial intelligence analyzing collected data are able to do it. The technology has developed to that level. The aforementioned all-robot production adjustments include all of the welding, joining, mounting, even painting, which the robots QC themselves, plus installing EV, hybrid, or combustion engine powertrains in succession on the same production line. The factory in Japan's Tochigi Prefecture is scheduled for full production mode in April of 2022. Nissan said the innovations being tested in Tochigi will be gradually rolled out to its other global plants, including French alliance partner Renault's factories. Nissan has announced plans for $1.14 billion in enhancement for its global factories. $290 million was invested in the Tochigi plant. Tochigi is the third key production facility for Nissan in Japan, after Kyushu and Opama, each with a production capacity of about 250,000 units annually. That's over 2,000 vehicles a day per auto plant. Of course, with a global shortage of computer chips ongoing, those lofty production numbers may be hard to pull off. The dexterous five-fingered cobot hand. What's the next big breakthrough in tech for cobots? How about a dexterous, sophisticated five-fingered hand? How about the next time you go to the symphony, the conductor is just a pair of hands on a podium? Say a clone of Stravinsky's hands, conducting in the exact same way Stravinsky conducted The Rite of Spring. In Frances Negrello's Hands in the Real World, featured in Robotics and A&I, she writes, "The human hand's ability to interact with the world for crafting, exploring, and even conveying emotions is one defining human characteristic that has inspired scientists and innovators for centuries." Well, maybe not as glorious as a Bernini or Rodin's hands in stone, technology is closing in on a dexterous, sophisticated, five-fingered hand for cobots. Cobotics that first gave us that marvelous arm and lately filled it with sensors, compute power, and machine learning, now may be readying to offer up the ultimate tool, a five-fingered hand, a near clone of our own. Of the near 24 global R&D projects for five-fingered hands, only 2 have been certified for real-world marketplaces: QB Robotics Soft Hand and Shunk's SVH for collaborative operation. Lately, artificial intelligence firm OpenAI gave it a try with Dactyl, using their humanoid robot hand to solve a Rubik's Cube, with software that's a step toward more general AI and a step away from the common single-task mentality. DeepMind created RGB stacking, a vision-based system that challenges a robot to learn how to grab items and to stack them. Now comes PhD student Tao Chen, a member of MIT's Improbable AI Lab. I love that name, Improbable AI. And he's the lead researcher on a dexterous hand system that can reorient over 2,000 different objects with the robotic hand facing both upwards and gravity-defying downwards. This ability to manipulate anything from a cup of tea to a can of tuna could help lead the hand to quickly pick and place objects in specific ways and locations, and even generalize to unseen objects. Our system, says Chen, will allow a multi-fingered hand to dexterously manipulate tools, which opens up a new area of robotics applications. Still a ways away from Negrello's hands in the real world, this breakthrough could well be the cobot's next great gift to industry. Imagine the sight of a factory floor filled with cobot arms and dexterous five-fingered hands tending CNC machines as elegantly as Stravinsky conducted.